Okay, well, good evening. I'm John Cussans and I revel in the job title of Weed Biology and Management Specialist at NIAB. So I run our integrated weed management, weed biology and some herbicide efficacy, herbicide resistance work that we do at NIAB. I have a background in weed science. I worked at Rothamsted Research, which is a government institute, or was at the time before moving to NIAB. And I guess before that I worked at Imperial and University of Aberystwyth. So I've always had a fascination with arable weeds. It's been something I've always wanted to do, and it's nice to be able to talk about it to a slightly wider audience. So I am the specialist at NIAB. I coordinate that area of work. NIAB was originally a government institute. Well, it was actually originally something that was started up by private subscription, but it became a government institute, and it was all about promoting improving crop genetics, better seeds for better crops, and then that expanded into agronomy and management. It was, as with so many of those organizations, was privatized and is now a much more diversified not-for-profit organization that has molecular genetics and a transformation lab, all sorts of areas of work. We work on a mission which is to promote science into practice in agriculture. So we support the farming industry at all different levels, whether that's individual farmers and their advisors, but also increasingly it's about providing facilities and support for individuals who maybe don't have the wherewithal to bring their innovations into the industry. And that's a bigger part of all the former institutes these days. So most of what I do at NIAB day to day is all around supporting practical weed management, promoting integrated weed management, developing different tools in integrated weed management and explaining how they can be deployed to the farmers and advisors. What I'm going to talk about today is really going to reflect that. So if you were hoping for a talk that was all full of genotype by sequencing or ecosystem service disprovision, I'm afraid you'll be a little bit disappointed. It's very much my take on the practical business of managing arable weeds and where we're going in the future. So arable weeds, to me, arable habitats in general, are massively underappreciated and not considered enough when we think about our resources and our biodiversity across the whole of the UK. Agricultural land is about 72% of the whole of the UK. The croppable area, which is a bit of jargon, but basically it's the potential arable land area, is about 6.1 million hectares. Over half of that is in cereals at any one time. And that's important to understand because arable farming at the moment, cereal crops are by far and away the most profitable. In fact, there are very few other crops that make any money at all. Maybe oilseed rape is second, and then there's a whole load of other crops, break crops, which really are grown at a loss in the rotation. And that does mean that cereals, in particular winter cereals, have come to dominate the landscape and dominate the UK arable farming. So to put that into context, if you think about the protected areas in the UK, sites of special scientific interest and so on, that's about 1.1 million hectares, and that includes freshwater areas. So it's a very large area, pool of natural resource that we need to tap into and think about more and more. But one of the features of arable agriculture is how disjointed and granular the management of those arable areas are. So if you look at the bottom, I've just produced the latest statistics from DEFRA, and you can see that most of the enterprises, holdings, individual farms are small, sub 100 hectares, and the minority is over 100 hectares. Obviously, as with so many other things in life, it is the minority that own the majority of the capital, so the actual area. But we're talking about a habitat that's difficult to access, difficult to understand. It is people's homes as well as their workplace, and it's also a workshop, an industrial, a place of industrial activity with heavy machinery. So it is a very difficult habitat to access and understand. In terms of arable weed species, we have about 150 to 200 species This is quite a nice resource. AHDB produced something that's called the Encyclopedia of Arable Weeds. It's got a really nice sort of potted summary of all 200 of those species. 34 of those species are actually relatively uncommon or even very rare. And these are species which we need to think about in terms of conservation rather than management. The reality is that because of the nature of these arable habitats, their difficulty in accessing them, a private land, the ownership is very disjointed and fragmented. There are actually very few systematic surveys of arable weeds carried out repeatedly over time. So it's quite difficult to understand trends and overall changes. There have been attempts to bring together multiple different surveys, and this is something that Robinson and Sutherland back in 2002 did. This is a whole range of different studies, and they make the point that the density of weed seeds in the seed bank does seem to be in decline over time, and that does reflect intensification in arable production over that sort of time scale. But it doesn't mean, that hasn't meant actually that we've lost too many of those 34 odd relatively uncommon species. They've been relatively resilient and robust in terms of there still being pockets out there, but the overall densities have certainly been in decline. And if you're interested in rare arable weeds in particular, I really recommend the work, having a look at the work that Plant Life have done. Philip Wilson and Plant Life have put together some really nice guides around rare arable weeds. So how do we pick up changes, monitor, and understand? Well, it's very much about networking, networks of farmers. We are right now, through the winter, we're going to be doing our events, and then through the summer we work small groups of farmers, again talking about integrated weed management. And then of course on top of that we carry out our own surveys. So if a particular weed issue comes to the fore, people are talking about it more and more, you can see patterns across the country, we will go out and either ask people to send us weed seeds or collect weed seeds. You can see here my assistant is collecting black grass from a site just outside Hertfordshire. She was a very willing assistant until she got to about the age of 12, and then it completely dropped away, but nevertheless she was very much part of the mix. So before we talk about specific species, I want to talk about, how do we get to weed communities in the field, the actual weeds which individual land managers and farmers and owners are dealing with. Well, we start with that species pool, which is, I think, much larger than a lot of people think about, this 200 odd species. And then locally, we have a set of environments, soil types, climate, and so on, which act as a sieve to bring you down to a local species pool. And in any one locality, the work that's been done, people like Jonathan Storkey at Rothamsted and so on around this subject, so there probably is a local species pool of no more than about 50 to 100 species. Much smaller on some of these slightly more marginal arable lands, slightly larger on more productive, moisture retentive soils. But the key thing is that from that, what is the potential weed flora in an individual field? By far and away, the biggest impact is the crops that we're growing and the management of those crops, so rotations and agronomy. And that sieve, that selection, where we have species which are potentially present in the field, and then the rotations, the crops, the way that we're growing crops, really select from that the weeds that become dominant in the field. This is the overarching mechanism by which we end up with weeds in individual fields. And it's been trends in this crops rotations management which have really driven a situation where we have we've ended up with something which, as a result of intensification, the finances of crop production in the UK, we are coming from quite a bad place, I think that's fair to say, in terms of sustainability for weed management, but also sustainability for farmland, soils, natural capital, externalized costs of agricultural production as well. We, through a process of intensification and finances and a certain amount of consolidation of arable land, we ended up with winter cropping completely dominating rotations. The diversity of crops that are being grown is very limited, and that's a product of a lack of profitability for many crops and this domination of cereals. The use of spring cereals, which was historically quite high in the UK, dropped to a very, very low levels, perhaps a few percent for things like winter wheat and for spring wheat and spring barley, for example. And although we saw a reduction in inversion, which was the traditional, almost pre-pesticides approach to crop establishment, that didn't mean that the intensity of cultivation that was going on in fields dropped. We had an evolution of something which you describe as Maxitill, so deep non-inversion, single pass, cheap establishment systems, but still cultivating and mixing a large volume of soil to depth. And a lot of energy is going into those soils, damaging the soils which need to be repaired. So these are just cropping figures from DEFRA, and you can see dominated by wheat, oilseed rape, which has dropped subsequent to this because of some issues around one particular insect pest, and then winter barley being the other dominant crop. So we've got really homogeneous rotations out there. It's not particularly healthy. All of the crops that we grow coincide with a life cycle of a number of key weed species, which I'll talk about. And being grass weed crops, grasses in these grass crops are more difficult to control, and they very much have come to the fore. Some statistics, very difficult actually using DEFRA statistics to split winter from spring cropping, but this is some data back again from Sutherland and Robinson. If you look at the percentage of winter sown barley and the percentage of winter sown wheat, conversely the drop in spring sown area, you can see that historically there was quite a lot of spring production cereals, and now it's completely dominated by winter production cereals. The other dynamic which happened over this period is because of effectively yield potential, we saw a dramatic move to earlier and earlier establishment of these autumn sown cereal crops. So this is a survey which DEFRA do, it's actually carried out by fore now, where they look at a whole collection of first wheat crops, so the first wheat grown in a rotational sequence. And you can see that the percentage of this first wheat crop area that's drilled in September has expanded over time. And even the first half of September, we reached a point where nearly 1 in 5 of these first wheats were being drilled in the first half of September. And what that does in terms of weed management is it closes down the window between the harvest of one crop and the sowing of another crop. All of the opportunities to get weed control outside of the sown crop are dramatically reduced, and it moves the drilling of the crop into the maximum germination window of some of these key weeds, which we're going to talk about. And then through the same time period, we've seen ploughing. So the percentage of first wheat fields which are ploughed has dropped dramatically. It dropped a little bit during sort of fuel crisis era, but has dropped dramatically recently, certainly since the early 90s. And just recently we've seen just the beginning of direct drilling. So this is non-disturbance approaches to establishing crops, which I want to talk about a lot more at the end when we talk about emerging weeds, because I think that's one of the key things that we need to think about a little bit more. But this trend, this downward trend in a reducing percentage of crops which are being established using a plough doesn't mean a reduction in cultivation intensity. What we've actually seen is the evolution of these Maxitill systems. So high horsepower, lots of energy, cultivation trains effectively with working with multiple modes, with discs, tines, and sometimes a packer roller on the back. So not inverting the soil isn't actually no-till, it's Maxitill. And this cultivation system, which is very cost effective, single pass, is much cheaper, facilitated by ever increasing horsepower in the tractor, is a really bad scenario for grass weed management, because you mix the soil profile, create a persistent seed bank by burying a certain fraction of the seeds, but because you're not inverting the soil profile, you're not actually burying freshly shed weed seeds very effectively. So it's a sort of nirvana. It has proved to be a nirvana for certain grass weed species. So those kind of three elements together led us into a really quite unsustainable place from management. Fundamentally, we got to a point where so much of our grassweed management came from in-crop selective herbicides, and there's simply not enough deployment of non-chemical control, cultural management through rotation, thinking about opportunities outside of the crop. And what of course happened is we developed very rapidly herbicide resistance to these same in-crop selective herbicides, because so much of the weed control was achieved through the use of in-crop selective herbicides. You know, weed management in practice is really a series of knobs and dials that you can twiddle to get everything in equilibrium. And in this sort of evolution of this system, we really turned the dial for in-crop herbicides up to 11 and turned all the other dials down. And that's really been the root of the evolution of so many of our problem weeds on farm. So we've ended up with weed management decision-making dominated by very few grass weed species, and this is associated with the development of herbicide resistance. So our key weeds and the weeds that we get asked about every single, well, pretty much every day in the summer, but certainly every month outside of that, are Alipocurus myceroides, blackgrass, Lolium multiflorum, which is an annual ryegrass, so not Lolium perenne, but it's also Lolium multiflorum exists in the UK as an arable weed form, which is separate from the use of ryegrasses as a forage crop. So it's quite a distinct genotype that's existing in parallel to the use of Lolium in forage crops. We also traditionally have always had wild oats, but that problem has been exacerbated by the evolution of this system. And it's two species, and that's something I want to talk about a little bit, because there's a really interesting trend between the two species over time that we can pick up, but also a whole range of brome species around Bromus comitatus, your soft brome, rye brome, meadow brome types, but also these Anisantha sterilis species. There is a which is sterile brome. There is also a giant brome species, Anisantha diandrus, but that's much rarer in practice. So those are the weeds which have come to absolutely dominate. So we start with 200 odd species. We end up with 4 or 5 which completely dominate decision making on farm. You see that in surveys of farmers. So this is some work that Monsanto started. Obviously Bayer's bought Monsanto out. This is their national grassweed survey. Hundreds of individual farmers surveyed, and you can see we're down to a very limited number of grass weeds. So effectively blackgrass, which I'll skim over the problems right now and then talk about emerging weeds as advertised in a little bit. So this is Alipocurus myceroides, beautiful weed. The starts off with this very distinct foxtail. The foxtail then darkens as the seed ripens. That gives you the name blackgrass. It almost is a sort of beautiful shiny black across the top of the crop at maturity. This is just a drone photo of a field trial with, on the right hand side here, drilling in October, and on the left hand side here, drilling in September, just to show you first of all the impact of drilling date. So that trend in earlier drilling leads to these sort of heavy infestations, makes your herbicides work much harder, but also the potential to deploy relatively simple cultural control approaches to really help manage the weed. So we've ended up in terms of blackgrass, it started in about 1982 with a single site in North Essex. This is a survey that was done by colleagues in ADAS, funded by BSF, where we've now reached the point where something like 75% of the samples in this survey are resistant to our 2 major contact acting in crop selective herbicides, and they in this instance carried out 3 different tests. About 60% of all these samples show significant resistance across all 3 tests. Only 2% remain sensitive. So with blackgrass, that we're really in the end times in terms of relying on in-crop herbicides. We've seen enormous reverses in practice to help overcome this weed. It's a self-inflicted problem, honestly, but it is something that we're seeing massive progress with coming from these kind of situations. We're also seeing the rise of Italian ryegrass. So again, just a drone photo to show Plowing, drilling date. So again, that drilling date dynamic, using spring crops in the rotation, we can achieve massive impacts on arable weed, problematic arable weed populations with really quite simple changes, just dialing up some of those other knobs and dials in the weed management armory. We can really reduce the need for in-crop herbicides and achieve so much. So Italian ryegrass, this is a survey that we're carrying out right now, actually, summer 2021. And you can see that's 200 plus respondents. You can see the kind of problem that the weed can be in practice. This is a plot that we drilled at an arable show, the cereals event in the summer. But you can also see we have quite clear clustering of Italian ryegrass, and we always have. So it's not clear right at the moment, and indeed that's the purpose of the survey, as to why the ryegrass problem remains so clearly clustered in these problematic areas. Nevertheless, where it is a problem, it is reported to be an increasing problem and a very severe problem. And again, you know, it's chicken and egg as to whether herbicide resistance is the reason for this problem, or the abundance of this weed on farm is the reason for herbicide resistance. But what we see is increasing proportions, increasing prevalence of herbicide resistance in this weed. So again, it's put in a slightly different way, I'm afraid, but you can see here we have tested for Atlantis, which is a so-called ALS mode of action herbicide, Axial, which is an ACCase, and then flufenicet, which is actually a prophylactic soil acting herbicide. Very high prevalence of herbicide resistance in this weed. Slightly more complex pattern of cross resistance, and that's something we use a great deal when we talk to growers about matching herbicides to resistant status. So again, we have got into a very unsustainable position, or we did get into a very unsustainable position with respect to blackgrass and Italian ryegrass management. And then the other weed, which has always been a problem, but it's interesting to see how the nature of that problem is shifting over time, wild oats. So actually in the UK, we have 2 wild oat species. I think the identification of the different species is poor, if I'm honest, and not consistent. But we have common wild oat, Avena fatua, which is also referred to as spring wild oat. And we also have winter wild oats, which are Avena sterilis, subspecies ludoviciana, which are actually in the vegetative phase very difficult to tell apart. So we do rely on collecting seeds or identifying through mature seeds in the field. Avena fatua, you have these separate individual seeds with this very distinct bent, twisted genicular awn. So on exposure to moisture, they twist in quite an elegant way to bury the seeds. With Avena sterilis, the seeds are shed in this very distinct pairing. It's actually quite hard to separate the pairs. And also there is the occurrence of 3rd and 4th seeds in that unit, neither of which have an awn. And that's really diagnostic, because all the fatua wild oat seeds have an awn and some of these don't. So we have these 2 species which are not being identified particularly well. It's interesting to look back on Avena sterilis, subspecies ludoviciana, in the past. Common wild oats probably been around in the UK for as long as agriculture itself, probably before that, in truth. The first records of Ludwig's oat, this Avena sterilis, occur in the UK about 1910, 1912, probably coming into the UK as a contaminant of imported grain. So Avena sterilis is much more common in the so-called Fertile Crescent. Grain imports from around that area probably brought the weed into the UK. The first record, actually, winter wild oat as an arable weeds, 1926. The first dozen or so records all occurred in a kind of 5 kilometre, very tight area. So it did look like an event which had led to an invasion and spread. By the most recent, up to about 2019, you can see that there are a lot more records of Avena sterilis, subspecies ludoviciana, in the BSBI database, still confined largely, although not completely, to this band across central southern England. Some work that was done in the 1980s by my a former colleague, actually, Stephen Moss, suggested that in this central southern zone, Venus sterilis was occurring in about 1 in 10 wild oat arable weed populations. Certainly when I started in getting interested in weeds, Venus sterilis was an oddity. It was noticeable to find it. I'm quite pleased with yourself to find it. But just recently, in fact, in 2020, we carried out a wild oat survey ostensibly to look at resistance status in the species. And actually in that, we picked up that 30% of the samples that were sent in contained a Venus sterilis. So there's definitely some sort of shift from the spring type to the winter type, associated probably with this dominance of winter cropping, reduction of spring cropping, still largely concentrated in this central southern area, but really interesting that it's gone from a bit of an oddity to something which is much more something that we need to talk about, farmers and advisors, you know, about managing these two different species in different ways on a sort of monthly basis. So what we are picking up, or what we picked up from the survey, is the problem. We asked all of the people who sent 100 people who sent samples, is the problem increasing or decreasing? Much more people with the Venus sterilis, the Ludwigsiana type, said that the problem was increasing than did with the fatua. And that was reflected to some extent. These are herbicide resistance tests, a proportion of the samples that were sent in. We're seeing a lot more herbicide resistance in the Venus sterilis than we're seeing in the Avena fatua. It's against chicken and egg. Either a propensity to develop resistance is driving this increase in abundance, or the kind of cropping systems that we're seeing out there are driving abundance, and then that is driving herbicide resistance. But nevertheless, it's a really interesting trend, which I think has happened under the radar to a large extent. So really interesting to pick that up. And then obviously of the grass weeds that came to dominate our rotations, the last group in this case are brome species, largely rye and meadow brome, so largely the hordaceous and, or rather commutatus and seculinus. It's really interesting. Again, this is another area where something is happening a little bit under the radar. There was a physical survey, so 733 cereal fields were actually visited by the team in 1989, and they found no Bromus seculinus at all in the survey. Right now, it's occurring at roughly 50-50. So when we actually get a definitive ID, which is quite hard, so I do refer you, if you're interested, there's a really quite nice leaflet that's produced by something called Crop Protect, Brome Identification Guide. There's also a AHDB Brome project report, which gives you a little bit of background if you're interested in the species. Right now, we seem to be running at more like 50-50 when you get a definitive identification. Again, it's hard to tell exactly how herbicide resistance is playing into this dynamic, whether it's a part of it or whether it's just agronomy is favoring one species over the other. But the reality is, again, we've now got a situation where alongside the overarching problem of blackgrass, the increasing problem of Italian ryegrass, background of Italian ryegrass, of wild oats rather, we have 4 different species in the UK of brome, so bromus, bromes and anisantha, all of which have confirmed herbicide resistance. So we really got ourselves into a very uncomfortable position in terms of the sustainability of weed management. We got into a situation where weed management was completely dominated by talking about these weed species, and there was nowhere near enough conversation about weeds in general, about integrated weed management. Within that, there are obviously these really interesting shifts, this increase in Avena sterilis and this switch from meadow brome to rye brome as a problem species on farm, but nevertheless dominated by these early autumn emerging grass weeds in early autumn drilled grass crops effectively. So that's not a very great scenario to get ourselves into, but the reality is that right now agriculture in the UK is going through a rapid, radical transformational change where we're seeing a shift from that uptake of that agronomy system, that package of the crops that we grow and the way that we're growing it, to completely different ways of thinking about managing crops, growing crops, thinking about sustainability from soils, thinking about sustainability in terms of the IPM, including integrated weed management, and thinking about reducing the externalized impacts of agriculture, which have really always been something that we needed to address. Up until now, so today, in fact, I think DEFRA is talking about the environmental land management scheme, which will be the replacement for the subsidy support regulation direction that formerly, of course, was under the Common Agricultural Policy part of the EU. They have a sustainable farming initiative, which is associated with this environmental land management scheme, which is to promote the uptake of these kind of approaches in practice. Up until now, all of the thinking about supporting biodiversity, minimizing the impacts or mitigating the impacts of agriculture have largely, not entirely, and people get the wrong idea, it's been universal like that, but largely the focus has been on supporting biodiversity around the edges of fields and then farming the middle of fields, effectively or efficiently at scale, high input, relatively high output. So the focus has been on around that kind of 500,000 kilometers of hedges and tree lines and so on, and maintaining, increasing that stock, improving the stock. The area of farmland that was in agri-environment schemes about 3.6 million hectares, but most of that intervention was around field margins, linear features, taking marginal land out of production and so on. So interventions around the edge rather than actually changing fundamentally the way that crops are being grown, the practice in the middle of the field. So what we're seeing right now is a direction of travel, I'll say at the moment, not a universal uptake. And even where there is people are thinking about conservation agriculture or even something that's being termed regenerative farming, they're not necessarily adopting all the pillars simultaneously. But what we're seeing is the uptake of an approach which is called conservation agriculture, which is all really about soil conservation management, minimizing the impact of farming outside of the farmed area. So around minimizing soil disturbance, so not using all that horsepower to hammer the soil, no matter how cost effective it is, minimizing tillage, minimizing soil disturbance, replacing bare periods after the crop is harvested, before the next crop is drilled, even over winter, with permanent soil cover around using cover crops, even relay cropping, so sowing a cover crop into the standing crop, harvesting the standing crop, and then having a ground cover that lives through the whole year. And then associated with that, and in fact, a really important part of that is diversifying that crop rotation again, backing away from autumn cereal dominated landscapes into much more legume-based crops, break crops, different crops, niche crops in places, which may not be suitable for everyone, but really diversifying the crops that are grown. That has a massive impact on the way that the landscape looks. And I'm sure some of you have probably picked that up already. And then associated with that is something that's been described as regenerative farming. I mean, to me, they are basically the same direction of travel. Regenerative farming has 5 pillars. These 5 pillars around don't disturb the soil, chemically or physically. So maybe it's a slightly more radical thinking about soil disturbance, and then talk about keeping the soil living, keeping living roots in the soil. But again, that's the same as the second pillar in conservation agriculture, in effect, growing a diverse range of crops. But in regenerative farming, there's a move to bring grazing animals back onto the land, promoting mixed farming. I think for me, the question mark around that is whether we have lost that opportunity, whether mixed farming, bringing grazing animals and livestock is back into largely arable parts of the world where arable farming dominates, whether that's genuinely possible at the moment. We've lost all the infrastructure that would support that, but But basically these changes, this complete direct change in the direction of travel for UK agriculture, we're seeing that having massive impacts, reducing the dominance of those weeds that I've talked about so far, but at the same time throwing up really different problems that people perhaps aren't prepared for or ready for. So I'm going to talk about the species that we're seeing more and more of in farm, and some of the problems that we need to keep our eye on as we see that uptake of conservation agriculture. So this conservation agriculture or regen farming is very much at the heart of what DEFRA is trying to do with environment land management, sustainable farming initiative. So we're going to see these changes really embedded in the way that arable crops are grown in the UK. So each of those pillars has a massive potential impact on weeds. So I talked about that. What's the biggest sieve? What's the biggest determinant that selects from the potential pool of species to the weed species that we have in the field? It's the crops that we grow and the way that we grow them. What we're seeing is the uptake of direct drilling. So direct drilling is attempting to establish a crop with minimizing the disturbance to the soil. It requires a very specific piece of equipment, not a traditional soil crop drill that people have been using. We see that uptick in the crop monitor statistics in terms of direct drilling coming in under a separate category. But what we're seeing alongside that direct drilling minimum tillage is we're seeing more and more plant species which are perhaps some of them relatively common outside of arable areas, but they're able to persist and invade minimum soil disturbance habitats where they were formerly excluded by intensive cultivation. So species like Vulpia maiorus, which is rat's tail fescue, anthriskus corcolus, Bircherville, not associated really as problem arable weeds. We see that pop up more and more on UK farms. Quite localized, we're seeing more farmers with loose silky bent apara, which is a bigger problem on the continent, but also things like rosebay willow herb, yellow and purple nutsedge, where that no-till is allowing these species to survive and persist under those situations. But alongside that, we have these pillars around soil cover, introducing live mulches, cover crops and so on, non-productive crops, and diversifying the crop rotation. And here we're seeing the risk of the failure of biosecurity. We have a very mature and quite strong system for ensuring biosecurity in crop seeds. We don't have a similar setup for non-crop seeds. And what we're beginning to see, I'm seeing it in person, and agronomists that we deal with are more and more dealing with cases of this, is failure of biosecurity. So non-crop seeds being imported into the UK, and we're seeing outbreaks of parasitic weeds associated with some of those legumes that are being grown in those mixes, the loose silky bent again, and also things like barnyard grass, which is a big problem weed again elsewhere in the world. We're seeing that associated specifically with one particular kind of, it's called game cover, that people are using in field margin areas, invading the crops. But also with these it's not a chemical fallow or a physical weed control fallow. We've got living vegetation through this whole period. We're seeing an uptick in weeds that can complete their life cycle within the non-crop phase. So weeds with really short life cycles, more and more questions about ground soil control, and some weeds which perhaps had gone away out of our thinking. So what are we actually seeing on farm? Well, this is a really interesting farm. This is one farmer from near NIAB's headquarters in Cambridge. Over a 12-month period, he's an enormous proponent of this conservation agriculture approach. A lot of legume-based cover crops, even fertility building crops outside of the productive crops. And he's seen over the last 12 months Orobanche coming in vetch seed that's planted, but also Dodder, Cuscuta campestris, which is really, for me, has been really rare up until this point. And once those pictures went out on Twitter, there were about half a dozen people flagging up that they'd seen the same in their crop seed. So if Legumes, because we want to use less synthetic nitrogen, we want to build soil fertility, are going to be more and more important in the rotation. We do need to think about these quite specific weeds in these non-productive crops. And we're seeing more and more of them, which I think reflects a failure in biosecurity. More significantly and more worryingly, this is actually a few years ago now, but Orobanche crenata. So Orobanche crenata is bean broom rape. It has decimated faba bean, field bean production in parts of the world. It's one of the reasons why field beans became a profitable crop to grow in the UK. It wasn't possible to grow them. Your basic mainstay for managing these parasitic weeds is not to grow a compatible species as a crop. And that's a really challenging thing. So if we got more outbreaks of this Orobanche crenata, we would be in real serious problem in the UK. So this is a weed in particular that we have a very heightened level of monitoring that we're really talking about more and more to get people to spot it early on. Another failure of biosecurity in these non-crop seeds, this is a really common. So I went out to a former colleague whose father farms around Hertfordshire, Echinocloa criscalii. So on the left, you can see the weed has come in as a component of this game cover, which is grown to support pheasants, but also wildlife around the edges of fields, coming across into this spring crop. So this is a spring wheat crop in the UK with a patch of barnyard grass completely destroying the crop. Really something which would have been very exceptional. But actually, I went from this site in Hertfordshire to our own site near Cambridge, had a look in the game cover, and lo and behold, the same species occurs there. It's not being picked up in seed production. It's been mistaken for millet. If we got this as a significant weed in the UK, it impacts on our ability to grow late drilled spring crops. It's C4 is a really interesting weed globally, but it could have a really massive impact in the UK. So the other species, perhaps the most significant one that we're picking up at the moment, which is directly responding to the uptake of no-till, in effect, is this Vulpia, rat's tail fescue. So we did colleagues around Lucy Bushy did a survey based in Greenwich and found all of these different arable farms have problems with rat's tail fescue. It's a really interesting weed globally. It's not something we've seen in the UK up until a few years ago. And then very similarly, really tied to this uptake in min-till, direct drill, no-till type systems, we're seeing Bircherville, anthriskus caucalis, which, you know, you would dismiss in the normal course of things as it's not going to be a problem for arable weeds. You can see some of these sites where that Bircherville has got well-established, very high population levels. You can see the kind of impact on the crop. And here, it's particularly interesting that this is some survey that we did this summer right across the country. The only association that we could find is not soil type or management, it is no-till. This is a really interesting one because we didn't talk about this, we talked about this a bit at the start about these rare arable weed species. So anthriskus caucalis samples that were sent to us are being misidentified, or rather they're being identified as Bircherville, but they turn out to be something called shepherd's needle. Shepherd's needle, Scandix, is a rare arable weed that we need to conserve, but it's being mistaken and swept along in with this Bircherville weed. So overall, we're seeing these really fascinating subtle changes in some of the weeds which have dominated in the past, and we're seeing outbreaks of a whole range of quite different species that we've not seen a great deal before in the UK. But all of these changes are really keyed to changes in the crops that we're growing and the way that we're growing them. And I think I wasn't aware that this was going to be about climate change. But to me, the impacts of changing climate are going to be seen through the impacts of changing climate on agronomy, crops that are grown and practiced, long before they're seen in fundamental changes in this overall national species pool. So if we continue to have difficult, disrupted drilling periods in the autumn, people will tend to drill crops earlier or miss that out. And that is the impact that will have the biggest impact on the weed flora, rather than the changing temperatures or changing rainfall patterns and so on. So I was going to end there. I've run a little bit over, I'm sorry, but didn't get started on time. And ask if anyone has any questions about what we're seeing.
Thanks, John, that's great. I'll just stop the recording.